The objective of this lesson is to solve ratio problems using tape diagrams. In this lesson, students discover the structure of finding the numerical value of one unit in a tape diagram in order to determine the value of multiple units and solve ratio problems. The tape diagram, sometimes referred to as a bar model drawing or a strip diagram, provides a visual way for students to see part-to-part and part-to-whole comparisons. Let's take a look at our first problem. A comic shop's ratio of comic books to novels is 4:1. Let's make a tape diagram to model this situation. With tape diagrams, the boxes are equal in size and represent equal values. How many times greater are the number of comic books than the number of novels? The ratio is 4:1, with 4 being the number of comic books. If there are 4 comic books, how many novels are there? Let's use one red counter to represent each comic book in our diagram. We know with tape diagrams the boxes are always equal in value, and since there is only one counter in each of the comic boxes, there will only be one counter in the novel box. So there is only one novel because comic books are 4 times greater in number than novels. If each of the units were worth 2, how many comic books and how many novels would there be? It looks like 2, 4, 6, 8 comic books and 2 novels. Again, the number of comic books is 4 times greater than the number of novels. If there are 10 novels, how many comics are there? We could take the time to stack 10 counters into each box of the tape diagram, but what did we see with the previous 2 examples? The number of comic books is 4 times the number of novels, so if there are 10 novels, there would be 4 times 10 comic books, or 40 comic books. If there are 12 total comics, how many novels are there? We can take our 12 comics and divide them equally among the boxes. Since the total number of comic books is 4 times the number of novels, we can think 12 equals 4 times what? Or the novels will be 1/4 the total number of comics, or 1/4 times 12 equals what? From the model, we can see our answer would be 3. Let's solve another problem using our tape diagram models. The ratio of cats to dogs at a pet adoption shelter is 2:3. There are 36 cats in the shelter. How many dogs are there? Let's create a tape diagram by drawing equal-sized boxes to represent the cats and dogs. We need 2 boxes for the cats and 3 boxes for the dogs. There are 36 cats in the shelter. Let's label 36 above our boxes for the cats, meaning both boxes represent our total of 36 cats. The problem asks us to find the number of dogs, so let's draw a question mark by the dogs to remind us the answer we are looking for. If there are 36 cats, what would be the value of 1 unit for cats? We need to find 1/2 of 36, which is 18, so let's record that in each of the boxes. Now we can find how many dogs there are by multiplying 3 times 18, which is 54. There are 54 dogs in the shelter. Let's try one more problem. The ratio of home team fans to visitors is 10:3. If there are 650 people in the stadium, how many fans are representing the home team? So who and what is our problem about? We are comparing the home team fans to the visitors. The number of home team fans are 10 compared to the number of visiting team fans, which is 3. Let's draw 10 boxes for the home team fans and 3 for the visiting team. If there are 650 total fans, let's label 650 on the side, showing that both parts of our diagram total 650. The problem asks us to find the number of home team fans, so let's put our question mark above the home team fans to remind us the answer we are looking for. There are 13 total boxes between the home team fans and visitors, so what is the value of 1 unit? To find 1 unit, we need to divide 650 by 13, which makes each unit 50. By filling in the unit value on our tape diagram for each box, we can see that the number of home team fans is 50 times 10, or 500. Students continue to set up tape diagrams for a number of problems to practice. They set up situations using boxes to represent the units and solve problems involving comparisons of ratios. The objective of this lesson was to solve ratio problems using tape diagrams. We met this objective using tape diagram models to show part-to-part and part-to-whole comparisons.